Galileo Galilei was an Italian natural philosopher, astronomer, and mathematician who played a central role in the scientific revolution of the 17th century. He is widely recognized for fundamentally changing how humans understand the physical universe, shifting reliance from ancient authority to observation and experimentation. His work laid the necessary groundwork for modern physics and astronomy. Born in Pisa in 1564, Galileo was the son of a music theorist who questioned traditional harmonies through practical testing. This background likely influenced Galileo's eventual rejection of established scientific dogma in favor of empirical evidence. Although he initially studied medicine at the University of Pisa, he left without a degree to pursue mathematics, a field where he felt greater certainty could be achieved. Galileo's most significant contributions involved the application of mathematics to the study of motion and the use of the telescope for astronomical observation. In physics, he challenged the long-held Aristotelian belief that heavier objects fall faster than lighter ones. Through experiments using inclined planes to slow the motion of falling bodies, he established that acceleration is constant and independent of mass. He also defined the law of inertia, stating that a body in motion remains in motion unless acted upon by an external force. These principles were later incorporated into Sir Isaac Newton's laws of motion. In 1609, Galileo heard of a magnifying device invented in the Netherlands. He improved the design significantly, achieving magnification of up to 30 times, and turned the instrument toward the night sky. His subsequent observations were published in a short treatise titled Sidereus Nuncius, or The Starry Messenger. He revealed that the moon was not a perfect sphere, but was covered in mountains and craters, much like the Earth. He discovered 4 moons orbiting Jupiter, which proved that celestial bodies could orbit centers other than the Earth. Crucially, he observed that Venus went through a full cycle of phases similar to the Moon, a phenomenon that was only possible if Venus orbited the Sun. These astronomical findings provided physical evidence for the heliocentric model of the solar system proposed by Nicolaus Copernicus. This placed Galileo in direct conflict with the Roman Catholic Church and the scientific establishment of the time, both of which upheld the geocentric model, where the Earth sat motionless at the center of the universe. In 1616, the Inquisition declared heliocentrism to be heretical. Galileo was warned to abandon the theory, but continued his work. In 1632, he published Dialogue concerning the 2 chief world systems, which compared the Copernican and Ptolemaic systems. Although presented as a hypothetical discussion, the text clearly favored heliocentrism and was viewed as a challenge to papal authority. The following year, Galileo was tried by the Inquisition, found vehemently suspect of heresy, and forced to recant his views. He spent the remaining 9 years of his life under house arrest. During his confinement, Galileo compiled his life's work on physics into the book 2 New Sciences. This text formalized the study of kinematics and strength of materials. Today, Galileo is remembered not only for his specific discoveries, but for pioneering the scientific method itself. His insistence that the laws of nature are written in the language of mathematics remains a cornerstone of physical science.